Many teams assume that if a polyacrylic acid is labeled low metal, it's safe for electronics applications. But this is one of the most common failure points. Materials can pass incoming inspection and still contribute to yield loss, surface defects, or long-term reliability issues driven by trace metals that weren't controlled tightly enough. What teams often miss is that low metal isn't a single standard. For polyacrylic acid used in electronics, parts per million metal levels may appear acceptable on paper, but even parts per billion differences can influence surface interactions, metal ion behavior, and downstream process stability. The effects rarely show up immediately. They tend to appear and cause headaches later during qualification, extended production runs, or reliability testing. That's when materials interact repeatedly with metals, oxides, and engineered surfaces under tight process windows. In practice, this means electronics-grade polyacrylic acid can't be judged by a generic low-metal label alone. What matters is which metals are being controlled, how low they're measured, and whether that control is verified consistently over time. Without that visibility, a material can pass incoming inspection and still introduce performance or reliability issues once it's inside an electronics process. At Polysciences, our teams can work with you to determine whether trace metal control is truly aligned with your process, and to identify the risks that often aren't caught until qualification or scale-up. If polyacrylic acid is part of your electronics application, our technical team is ready to help you assess metal-related risks early, before they become yield or reliability issues. Visit polysciences.com to contact our team.